Hello again. In this video, we're going to look at using probability trees. So in this question, we're looking at a card is taken at random from a deck of cards. It's then replaced. Another card is then taken. We're asked to draw a tree diagram to show the probability of getting two aces. So we have two cards being drawn after the first one's replaced. So we look at this first of all as two possibilities. What we do is we draw two branches here. We're looking at the outcomes of card one first of all. And the card one is we can get an ace or we don't get an ace. First of all, what is the probability of getting an ace in a pack of cards? Well, there are four aces out of 52, which is the same as saying 1 out of 13. The chance of getting an ace is 1 out of 13. So therefore, the chance of not getting an ace is all the cards that are left, which is 12 out of 13. So that's the first card dealt with. So we repeat this now for the second card. So we're now looking at card two, and we've got two possibilities. One if you've chosen an ace, and one if you've not chosen the ace. Well, because that card was replaced, the first card we took out was replaced, we still have the same probabilities of getting an ace. So it's still 1 out of 13, and the chance of not getting an ace is still 12 out of 13. Same here, and same there. So now we've drawn our tree diagram, so we've done this part of the question. So now the question says, show the probability of getting two aces. So let me just take this away. Now to do that, the best thing I would suggest to do is use a highlighter and look at the chance of getting an ace. Well, an ace is here and an ace is here. So what path are you following? You're starting here, you're choosing a card, you're getting an ace, and you're going this way. So we're following this path here. So if you think about that, we have got 1/13 and multiplied by another 13th. So in this case, the probability of getting an ace followed by another ace is equal to 1 over 13 multiplied by 1 over 13, which is 1 over 169. Now we're not asked to do anything else, so we've done the question. We've got full marks for that. That's job done. However, I want to show you something. Now, what I would suggest you do is you understand the rest by working the rest out. So let's look at the next one down. So if we chose first card and got an ace, but the second card we didn't get an ace, what would the outcome be? Well, in this case, chance of getting an ace and the chance of not getting an ace will be 1 out of 13 multiplied by 12 out of 13. And that just gives 12 out of 169. Let's do this for the other two. Let's say the first card you don't get an ace and the second card you do. We are now looking at not getting an ace and then getting an ace, which is 12 out of 13 multiplied by 1 out of 13, and that gives us another 12 over 169. And let's look at the final one. So now we are going from here, not getting an ace, not getting an ace. So this the chance of not getting an ace and then not getting an ace is 12 out of 13 multiplied by 12 out of 13, which is 144 out of 169. You're probably wondering why I've shown you this. And the reason for this is I want to show you that the sum of those probabilities always equal 1. So if we take all of these and we add them together, we get 144 over 169 plus 12 over 169 plus 12 over 169 plus 1 over 169. So we know the sum of those will give us something over 169. 144 plus 12 is 156. So 156 plus 12 is 168, and 168 plus 1 is 169. So we get 169 out of 169. Actually, if we do that calculation, anything divided by itself is 1. So we can say the sum of all of those probabilities is equal to 1. Okay, let's have a go at another question. So in this question here, a coin is thrown 3 times. Draw a tree diagram to show all outcomes. So again, we need to draw that diagram to show all the outcomes. And then we're going to find the chance of getting 3 heads or at least 1 head. So the same thing again, we start with the branches of the tree. Coins thrown first of all once. So this is throw number 1. It's either a head or it's a tail. And we know the chance of a fair coin getting a head is a half, and the same as that as for a tail. So let's do the second branch. This is our second throw. So now we've got a head and a tail going on here. I'll repeat that one here, a head and a tail. And again, every probability we are looking at here is a half. And then the final set of branches for the third coin being thrown, we are still looking at a head and a tail, head and a tail, a head and a tail, and finally a head and a tail. And again, they're all probability of a half. Right, so the question says, what's the chance of getting three heads? So let's have a look at that. So we've got a head, head, and a head. So we multiply those together. So the probability of getting a head, and a head is a half multiplied by a half multiplied by a half, which is 1 over 8. So we've done the question about getting head, 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 and we have found that that is probability of 1 over 8. So our next question is, what is the chance of getting at least one head? So we can do this in two ways. We can look at all the possibilities of heads, anything with head on it, so we can just work out those probabilities. Alternatively, we could have found all the tails and worked out those probabilities and taken them away from one. However, because we've done one of the heads already, we'll stick with finding heads. So in this case here, the probability of getting a head, tail, head is a half times a half times a half, which again is 1/8. Likewise, we have got the chance of getting a tail, a head, and a head, a half times a half times a half, which again is 1/8. And finally, the chance of getting a tail, and a head is still a half times a half times a half, which again is 1/8. So the probability of getting at least one head is equal to 1 over 8 plus 1 over 8 plus 1 over 8 plus 1 over 8, which is 4 over 8, which is a 50% chance. Well, that makes sense when you think about all the probabilities are the same because it's just two sides and equal chance of getting either side. So now we have done the second question and we've found the chance of getting at least one head is 50%. Okay, let's move that forward. So we're going to look at some probability trees where one outcome is dependent upon the other. So if you look at the last one we did, it didn't matter what happened in the first outcome. The second one had the same probability as the first one. So we're looking again at cards. So in this case, a card is taken at random from a deck of cards and then not replaced. In other words, you start with 52 cards, you take a card out, and you're left with 51 cards. After that, another card is taken. Now we need to find the chance or the probability that both are jacks. So we're going to use a probability tree to do this. So like before, we start with the branches. We have got card one, and we're looking for a jack, and we're looking for not getting a jack. And then we're looking at card two, and we're still looking for a jack and not getting a jack. And both the same down here. So remembering your cards, there are 4 jacks in a pack. That's 4 out of 52. So we know the probability of getting a jack is 4 out of 52. So we have 4 out of 52. Now, I wouldn't simplify this at the moment. And you'll see why later on. And we're looking at 48 out of 52. So this is why I wouldn't simplify it, because we start with 52 cards. There are 4 jacks. We take one jack out. How many jacks are left? There are 3. Out of how many cards? 51. So we know the chance of getting another jack is 3 out of 51. Just makes it easier now to kind of do this second part by not simplifying this. So how many cards are not jacks? Well, we know it's out of 51 and we only took a jack out. So we've got 3 out of 51. What's remainder? It's still 48. So we still haven't taken jack out. So it's 48 over 51. And again, the 48 plus the 3 should equal 51. And this is where it gets different. So these probabilities are not the same as these because this is dependent upon what happens here. These are dependent upon what happens here. So in this case, not getting a jack is 48 out of 52. So we have now taken one card out. That leaves us 51 cards. So we know both of these are out of 51. Now, chance of not getting a jack. So we did not take a jack out, which means there are still 4 jacks left. So that's 4. And 51 minus 4 is 47. So now we need to answer the question. Find the probability that both are jacks. So here we go. Well, that's a jack and that's a jack. So we are finding this probability here. So the chance of getting a jack followed by a second jack is equal to 4 out of 52 multiplied by 3 out of 51. And that gives us 12 out of 2,652. And if you simplify that, you'll get 1 out of 221. One more question. So in this final question, the probability that I forget my coat on a Friday is 25%. If I forget it on a Friday, then the chance I forget it on a Saturday is 20%. If I do not forget it on the Friday, the chance I forget it on the Saturday is 50%. Find the probability I forget my coat on just one of those days. So let's start with two branches. So I either remember my coat or I forget my coat, so I have no coat. Looking at this question, the chance I forget my coat on a Friday, so I'm going without my coat, I forget my coat, is 25%. And the chance that I don't forget my coat is 75%. And that's because those two probabilities need to add up to 100%, which is 1. So we've done Friday. So let's look at the next two. So now we're looking at Saturday. If I forget my coat on Friday, so here we go, I've forgotten my coat on Friday, then the chance I forget it on Saturday is 20%. So if I rewrite these as coat and no coat, so again, if I forget my coat on Friday, the chance I forget it on Saturday is 20%. And that's that bit dealt with. So if I do not forget my coat, the chance I forget it on Saturday is 50%. So I've got my coat, I haven't forgotten it, and the chance that I forget it on Saturday is 50%. So now I know that this pair have to add up to 100% and this pair have to add up to 100%. And the question now is asking, find the probability I forget my coat on just one of those days. So let's go with the first one. I've got my coat and then I forget my coat. So that's one to look at. Let's look at the second one. I have forgotten my coat. So therefore, the second one needs to be I have not forgotten my coat, because only it needs to be just on one of those days, not on both. So now we work these out. So the probability of coat and then no coat is equal to 75%, which is 75 over 100, multiplied by 50%, which is 50 over 100. We'll do that in a moment. And the second one, the chance of getting a no coat, then a coat, is 25 over 100, multiplied by 80 over 100. So what I would have done was this. 75% is 3/4, multiplied by a half. Well, 1 times 3 is 3, 2 times 4 is 8. And the next one I would have gone 1/4, multiplied by 4/5. 1 times 4 is 4, 4 times 5 is 20. And if you look at the 4/5 one, you should notice that actually you can cancel here. You can cross cancel. So 4 goes in there once and 4 goes in there once. So 1 times 1 is 1 and 1 times 5 is 5. And now we need to find out the probability of getting just one coat. That's combining those probabilities. So now what we've got is we've got 3/8 plus 1/5. Well, that is the same as saying something out of 40 plus something out of 40, because the lowest common multiple of both those numbers is 40. So I multiplied this fraction by 5. So 3/5 15. And I multiplied this fraction by 8. And 1/8 is 8. And therefore we add those together and we get 23 over 40. And that is the probability of forgetting the coat on just one of those days. Hopefully by doing that, you can see how useful probability trees are. And as always, if you've got something from this, please like and subscribe, and we'll see you in another video.